Hello and welcome to today's edition of Cracking the Cryptic, where we're going to, as usual on Saturdays, show you how to solve the deadly rated killer Sudoku that appears in the Times. So, welcome to the new subscribers. We have had quite a lot of new subscribers over the last few weeks, yeah, if you have any questions on any of the techniques that we'll show in these videos, just add them to the comments, and we try to reply to all the comments that we get. Without further ado, let's have a look at the puzzle. So the first thing I'll do is I'll just fill in the obvious options. So for example, in this top box where we have a 4 in 2 cells, that's going to be a 1, 3 in some combination. So that's what I'll do, and I'll just go through the puzzle and fill in this sort of obvious thing before we talk about the logic. Okay, so there's not many gimmies here, but there's a couple of things that we can note immediately. This cell and this cell are both immediately right-ins. So the reason we can deduce the value of these cells is that we know that every 3 by 3 box you see in the grid must add to 45, because it contains all of the numbers 1 to 9 exactly once each. So if you add the numbers 1 to 9, you get 45. And if we look at the boxes already contained within this top left-hand 3 by 3 box, the one that the cursor is showing here, we can see that we've got 3 boxes already entirely contained within this 3 by 3 box, and they sum to 18, 41. So 23 plus 14 plus 4 is 41, which means that this box must contain a 4 in order to ensure that the whole box adds to 45. And we can do exactly the same thing down here. So this cell is sort of isolated within this 3 by 3 box. So again, if we do the maths, we've got 11 plus 18 is 29, plus 8 is 37, so this box must be an 8. And then we can fill in the remaining options, which is 2, 5, 7, to make up this row of 3 in this cell here, like that. And the next thing you'll immediately see is, looking at this 21 box, we know these 2 cells now have to add up to 17, and the only way that that's possible is if they're 8 and 9 in some combination. So we should certainly be writing that down. Other things I'm noticing about the grid, just as I'm staring at it here with you, is if we look at this 22 box in 3 cells here in column 2, there are 2 ways that this box can be made up. It can be made up of 5, 8, 9, or it can be made of 6, 7, 9. Now, the common element in both of those alternatives is a 9. So we know that there is a 9 in one of these 3 cells. So we therefore know this cell cannot contain a 9. So we should make a note of that. The next thing I'm spotting is that the 13 here and the 18, both within this bottom 3 by 3 box, they sum to 31, which means these 2 cells have to sum to 14. And there's a couple of ways that they can do that. It could be 5, 9 or 6, 8, obviously. So, well, let's just complete the logic there. 5, 9 or 6, 8. Now, this cell here is a 30 in a box of 4. Now, the only way that that's possible is with one combination of numbers, which is 6, 7, 8, and 9. So this cell can never be a 5, because if it was a 5, these 3 cells would have to add up to 25. But the most they could ever be would be 7, 8, and 9. And 7, 8, and 9 add to 24. So this can't be a 5, which means this can't be a 9. Which means actually now our 9 is limited to one of these 2 cells in the 22. And I'll just, for the sake of good order, add the 6, 7, 8, 9, these 3 cells here, like that. And in fact now, I'm sure some of you have spotted this already, we can now write in the value of this cell. So if you can't see how to do that, just pause the video, give yourself a bit of time, and try and work out why I think we can write this number in. and in fact we can write this number in as well as a consequence of being able to write this number in. And the reason we can write this number in is if we look at the bottom row of the grid, we have an 8 here in this 24, which means that these 3 cells here must add up to 16. Now if we add this 16 to this 8, we get back to 24 again. But now these 3 cells have to sum to 21. And the only way they can do that is if this cell is equal to 9. So let's write that in. And that means this was in fact a 5. We should remove the 9 as the possibilities. Here, here and here. And that's really nice because now this 22, we know it's one of the 5, 8, 9 variations. So let's fill that in, which means this can't be an 8. So this in fact is a 6. And now just scanning using normal Sudoku techniques rather than killer Sudoku techniques, then we've got a 9 in column 3 already, so this can't be a 9, this has to be an 8. Oops, well, it would have to be an 8 if the software worked. There we go. And you can see now, again using Sudoku logic, we have an 8 here, we have an 8 in one of these 2 cells, therefore the 8 in column 1 is in one of these 3 cells, but it can't be here because of this 8. So it's in one of these 2 positions, and I'd certainly write that down because that seems like an important restriction. And again, just using exactly the same logic we've used so far, we can now isolate the value of this cell. Again, please pause the video, but it's exactly the same technique we've been using. We've got 17 here for these 2 cells, plus 8, 25, plus 19 is 44. So this cell has to be a 1 in order to make this box add up to 45. And again, something I would immediately be noting down here, because I'm scanning the columns all the time when I've got these options, and just using this 4 and scanning down, we can see the 4 has to go in one of these 4 cells in this 3x3 box. But actually we can go further than that, because the 4 can never appear in this 8 box, because otherwise there would then be 2 4s. So the 4 is in one of these 2 positions, and I would want to record that somehow. Again, I would be scanning across the row in row 4 to see whether or not that restriction was important. We haven't got enough numbers yet for it to be important, but let's try and remember that because it might be helpful later on. Okay, and there's something nice that we can note here. Now I'm looking at this box here, the one that I'm highlighting on the screen, and I can see I've already got a 6, 7 and 8 placed in this box in these 3 positions. I need to put a 9 in somewhere. Well, the 9 can't be here because this whole box adds to 8. So the 9 is somewhere in these 3 positions. So I would want to write that down. Shown. And the reason for mentioning this is what I'm trying to do is I'm trying to limit the position of the 7 in the bottom row, because I can see, and I hope that you can see, that I can't put a 7 in one of these 3 positions. That's for 2 reasons. Firstly, it's already a 7 in this box. Secondly, 8, 9 and 7 already add to 24, and I need to include more numbers in this 24 box. There's definitely not a 7 in one of these positions, which means there's either a 7 here in one of these 2 positions, which would make this 7 1, or there's a 7 over here. Now, if the 7 was over here, we would be left with 6 for the other 2 cells in this 13 box. And you can only make 6 in 2 ways, and the 1, 5 version of that would be ruled out. So this would have to be 7, 2, 4 in some order. Now, rather irritatingly, There's nothing I can see here that would rule that out as a possibility. But I wanted to show you that because that's the sort of thing I'm thinking about when I'm going through this. I'm really trying to make these restrictions work very hard. And we can use this same sort of, forcing technique up at the top here. And if we look at this 26 box, 26 in 4 is a reasonably restricted box. In the sense that it can never contain a 1. I mean, that's clear because then we would have to make 25 and 3. But the reason for looking at it here is that we've already got an 8 and a 9 in this 3x3 box here, which means I'm very restricted as to how this 26 can be made up. I could put an 8 or a 9 in this cell. That would be allowed, but I can't have an 8 and a 9 in this 26. And that's quite important because let's imagine that this cell wasn't a 9. Let's just have a think about what that would mean. If this cell wasn't a 9, we would have to make 26 in 4 cells without a 9. And a quick bit of mental arithmetic tells us that the only way of doing that is with 8, 7, 6 and 5. 8, 7, 6 and 5 do add exactly to 26. Okay, so let's just think about whether or not that's possible. Well, we can see that because of the 8, 9 we already have here, the 8 of this 26 would have to go here. The 7 can't go in either of these two positions because the 7 is, we've already isolated the 7 in row 2. It's in one of these 3 positions here. So the 7 would have to go here, which would leave us with a 5 and a 6 in these positions. Well, that's ruled out because look, we've already got a 5 here. So in fact, this is impossible. This variation, this 8, 7, 6, 5 combination is impossible. And because it's impossible, we now know that there must be a 9 in this 26, and therefore that must be here, because this is the only valid place for a 9 in this 4 box, because the 9 in these 2 positions rules out a 9 in any of these 3 positions. So you might say, oh, that seems a lot of work. I guess it is quite a lot of work, but it's, this is the sort of thing that's necessary to solve these puzzles relatively quickly. Now again, simple Sudoku logic on the bottom 3 boxes here. We have a 9 here. We know there's a 9 in one of these 3 positions. We know there's a 9 in one of these 3 positions. Well, now the 9 can't be here. So we should definitely note that the 9 is in this 18 box. It's not desperately helpful yet, but it may prove to be in a little while. And the interesting thing about this 26 box, once we've placed the 9 here, we know these 3 cells add to 17. We also know that these 3 cells add to 17 without including an 8. You cannot have an 8 in one of these 3 cells. So again, just think about how that's possible. 17 in 3 cells without an 8. Well, we could have a 7, a 6 and a 5 would add to 18. So the only way of making this box work would be if this was a 7, 6 and a 4. That's the only way of making 17 in 3 cells when you don't have an 8. There's no other way of doing it. And that's great, because now look, the 7 can't be here, so the 7 must be at the top here. Which means that's there we go. Which is very powerful indeed, because now I've got 2, 5, 6 along the top row. hopefully you can see immediately that the 5 and the 6 can't combine in these two cells, because that would give us 11. It makes this 10 too big already. Therefore, these two cells are either 2,5 or 2,6. Well, you can immediately see if they're 2,6, that would make this cell a 2, which is impossible. So in fact, again, just using this forced strict logic, this cell has to be a 3. And this cell has to be a 6. And now we need to place 1 and 8 in row 2. And this can't be an 8. So this has to be the 1, and this has to be the 8. And immediately again, we now know that these 3 cells are 1, 4, 7 in some order. So let's, 1, 4, 7 in some order. So let's put that in. But we can rule the 1 out from this cell, because this is a 4 box. This 4 box here adds to 26, so it can never contain a 1. So let's put 4, 7 in and ask ourselves whether one of these is ruled out. Well, we've got 14 already, so we need the other 2 cells to add to 12. Well, we can't have another 4, 8 because we've already got an 8 in the box. So this cell is in fact 7, and this is 5, which means neither of these can be 7. Which means these 2 cells add to 10. Let's just think about how that's possible now. Well, 1, 9 is ruled out because we already have a 1. 2, 8 is possible. 3, 7 is ruled out by this 7. And 4, 6 is ruled out by this 4. So in fact this is 2, 8, and we've already got an 8 here. So this is 2, 8 like this, which means we have to place 3, 5 in these 2 cells. And that's nice because this 8 box is now very limited. It has to be 3, 5, and it can't be 5. It's been quite a nice puzzle actually. You know, it shows, I think, the importance of really being strict with yourself and forcing yourself to think about some of these boxes with very high totals, especially if those totals are in any way restricted by what you already have in the grid. And we can use simple Sudoku logic again on the middle box here to place a 1. So just have a think to yourself how to do that. And I'll put the number in now. So obviously it can't go here because that would create 2 1s in the 18 box. And now just scanning down to the bottom 3 by 3 box where the cursor is now, we've got this 8 still here, where we haven't done much with that yet, but we know it contains a 1. And now the only position a 1 can be is here. And that's great, again, because we know that the remaining 2 cells in an 8 will either be 2, 5 or 3, 4. Well, 2, 5 is ruled out, so we've got the 3, 4 variation here. And I'm sure you're all noticing that's going to allow us to fill in a whole load more numbers now. This has to be 6. This has to be 4. Okay, 4, 4, 4. And now, we now know that we've got 2, 5. So this whole 24 box now is 8, 9, 2, 5. Let's put that in. Oh dear, sorry, I didn't mean to do that. How do I delete that box? 2, 5, this can be a 2, and this can be a 5. Now let's scan across and see whether that's useful. We have an 8 here. Can it be 1, 7? Yes, it can. Can it be 2, 6? No. Can it be 3, 5? No. So this is 1, 7, and we've already got a 7 here. So 7, 1, like that, which means this is 6, 3, 4 in some combination. We can't quite tell how that's going to look yet. It's going to be 3, 4, and that's got to be 3, 6, like that. And now I'm looking at this 11. So 11, there are 4 ways of making 11 in 2 cells. 5, 6, well that's still possible. 4, 7, that's not possible because of this 7. 3, 8 is not possible because of this 8. And 2, 9 isn't possible because of this 9. So this is 5, 6. And we already have a 5 here, so this must be a 5. And this must be a 6. 5, 5, 6, 6, 6, 6. This can't be a 6 now. And this 5 here must go here. Like that. This 6 box here must be 2, 4 because it can't be 1, 5 because of what's already in the column. Let's fill that in. Now this cell we now know that the 9 in column 9 must be in this position because we'd already done work to show ourselves that the 9 was in one of these two positions in this 3 by 3 box. We need a 9 somewhere in column 9, so it's got to be here. And that means that this cell is a 3, I think. So this cell is a 3 and this cell is a 4. Which means we've got to place 2, 4 in these two positions, and this 4 here forces this to be a 4 and this to be a 2. And I suspect now we've broken the back of the puzzle. We'll carry on a bit longer just to absolutely prove it to ourselves, but I think we've done the hard work. So again, now we can use killer Sudoku logic on this 3 by 3 box to force the value of this cell. Let's think about how we do that. Well, we've got 21 here, plus 5 is 26, plus 6 is 32, so these two cells have to add to 13 to make this whole box add to 45. Plus that is 14, therefore this is a 5. Therefore this one down here is a 9, that has to be a 2, and this has to be a 5. It's all quite helpful. And you should be able to see again now that we can now write these two digits in. Again, if you're not sure how, immediately just give yourself a moment to think about why. I'll tell you now that these two cells add to 13. It can't be 4, 9 because of the 4 here, and they can't be 5, 8 because of the 5 here and here. So we're looking at the 6, 7 variation, and the only way that works is if we do it like that. So we now have to place 1, 3, 8, 9 in these 3 cells. Quick check, yeah, they do add up to 21. Well, the only place a 1 can go is here. The only place a 3 can go is here. 8, 9. Now looking across here, this must be a 9, this must be an 8. Okay. And again, we can use sort of Sudoku logic here. If we look at the 2 here and the 2 here, we know that the 2 in column 4 is in one of these 3 positions. Well, if either of these was a 2, the other cell would have to be a 9 in order to fulfill this 15 box. So that's not possible, so this must be a 2. So we've now got 2 and 1 in an 18 box already, so these two cells have to add to 15. But they can't include an 8 because the 8's ruled out by this 8 and this 8. So the only way of doing that now is with 6, 9, and that is restricted to that possibility. Now we can put on 2 and 4 actually, looking across. That means this is a 3, and this is a 5. Which means this is a 3 and this is a 1. And 3, this must be a 3, 4, 6, 4. So you can see it's all coming together quite nicely now. 2, 3, we've got to place 4, 7 here. The only way of doing that is like this. When I'm doing this, I'm always sort of checking the totals just to make sure. It's very easy to make an error, especially if you're doing this at speed. And it's the most irritating thing as well if you make an error in one of these, especially later on. 7. We've got to place 2, 6 here. You can see the only way of doing that is this. This is a 7, this is a 2, and this is a 5. Slowly but surely we're getting there. So this has got to be a 2, I think. This has got to be a 1. Which means we need a 7 in one of these two positions. But this has to be a 7. So this is a 7, this is an 8. This is an 8, and we'll fill that in a second because it'll do all sorts of things when I fill this in. But I hope this was helpful. I've gone through it relatively rigorously today because, as I say, we do have some new subscribers. So I hope that those of you interested in Killer Sudoku have found this it's reasonably easy to follow. Any questions, comments, please leave them under the video, and we'll see you again next time on Cracking the Cryptic. For those of you interested in the crosswords, there's a really great video, I think, today where Mark's solved the Bletchley Park entrance exam puzzle from January 1942. Definitely worth a watch. Anyway, thanks for watching.